So again, hello everybody. My name is Nick Rendell. I work with Technical Toolboxes, and today we have a great webinar on API inspection and kind of looking at what are the historical practices of how we run the various API inspections, how there tend to be a lot of bottlenecks and how this happens, and looking into some of the ways that in this new era of software and more automation of how we kind of get around those. And today, our speaker is Jeff Walling, and he is a longtime expert in the arena of API inspection, brings a lot of years of expertise to the field, and also is unique because he helped develop the API toolbox that we use today. So he's kind of seen the issues firsthand with his experience in the field, and also looked at how to solve them as well. So with that, maybe we could move slides over to our agenda. So what we're looking at today, we're going to kind of break down an API inspection, how it typically happens, where are the bottlenecks in the process, and where we think things can be improved. Here at Technical Toolboxes, we like our webinars to be as interactive as possible. So, I like to say you're going to get out of this event what you get put into it. So if you do have questions throughout, look on the upper right-hand side of your webinar window. There is a little question box. Feel free to ask questions throughout. At the end, we're going to leave ample time to answer as many as we can. And if there's anything we can't get to, which happens sometimes, we will go ahead and follow up with you via email after the event. So with that, I'm going to pass it over to Jeff, and he will go ahead and get started. Thank you.
All right, guys. Thank you guys for this opportunity to be able to share this software with everybody. So some of the things involved in the bottleneck of doing inspection reports and inspections. API inspectors spend too much time on manual reporting instead of field work. Asset owners lack access to real-time inspection data for maintenance planning. Compliance teams struggle with tracking traceable, verifiable, and complete TVC documentation. And operators face regulatory risk due to missing or inaccurate inspection records. All this stuff adds up and it compiles, and it makes a bottleneck that does not necessarily need to be there. All right, so API inspectors spend too much time on manual reporting instead of field work. Okay, we have a little spreadsheet here kind of showing how that works. On average, the process takes approximately 2 to 3 days or longer. For usually it's like for 1 day in the field, and many involved 2 to 3 days or longer for 1 day in the field, and may involve multiple technical personnel. Okay. So you might be out there doing inspection on 10 tanks or whatever, and then it's going to take you several days, probably even on average even more. Factors such as drawings, photos, data entry, calculations, and written reports contribute to the overall duration. Okay, so many inspectors or engineers excel in certain tasks, but many may lack proficiency in others, such as doing AutoCAD drawings, doing calculations, data entry. For example, many API inspectors, particularly circuit writers, most you 510 guys will understand that, primarily conduct visual inspections and generate basic write-ups in Word documents, which this limited scope of experience can leave them unprepared when a new job assignment requires a comprehensive report. That includes a detailed write-up, inspection drawings, calculations, and data entry as outlined in the API inspection codes. So without a user-friendly software solution, inspectors face the challenging task of piecing together multiple programs such as Microsoft Word, Microsoft Excel, drawing tools like Paint or AutoCAD, and Adobe. So we got to deal and piecemeal these reports together. Okay. Once all the components are complete, they must be converted to PDF format and manually compiled into a single report, adding unnecessary complexity and inefficiency to the process. So this is our normal experience outside of a software. Okay. Okay, so yeah, this is what we just went over. So it's a piecemeal situation. It causes time. It's very time consuming to go through all this. Okay. Um, yeah. Okay. So challenges of using Excel spreadsheets. So let's just kind of look at some of this stuff. So normally a company will have a bunch of Excel spreadsheets with all the different calculations, their different components, different circumstances, remaining life, all this other stuff. So relying on Excel spreadsheets for inspection reports presents several inefficiency and risks. File management complexity. So, inspectors must locate and compile the necessary component files, often buried among dozens of similar spreadsheets. This process requires careful searching and organization, leading to wasted time and potential errors. Some of the more complicated calcs, such as horizontal tank evaluations in accordance with the Zick formula, Appendix M calcs for tanks greater than 200 feet, are often not a part of the Excel component library. So there's that you may not have all the spreadsheets that you need to do a really comprehensive evaluation. Then you have repetitive data entry. So common information such as vessel ID, client name, diameters, material specification must be manually entered into multiple files, increasing the risk of inconsistency and errors. All right, so the same data that has to go into each one of these spreadsheets, a shell calc, a head calc, nozzle calcs, same data, you got to repeatedly put it in. There's time, that takes time. You have component complexity. Okay, so a typical pressure vessel consists of multiple components, including cylindrical shells, nozzles of various sizes, and different types of formed heads: hemispherical, toruspherical, ellipsoidal, flat, conical. And then you got to figure out what's the difference between a ellipsoidal head and toruspherical head. Which one is this? Managing these variations across multiple spreadsheets can be cumbersome and error prone. Anybody that has to deal with these knows what I'm talking about. Data entry risks. Okay, the spreadsheet cells can be accidentally or intentionally overwritten by users, leading to critical calculation errors. Without proper version control or protections, these errors may go unnoticed until they cause some significant miscalculation issues. So that happens all the time. All right, time consuming and frustrating processes. Manually updating and managing individual spreadsheets to complete a report is inefficient and tedious. The lack of integration between files makes compiling file reports as a slow and frustrating task. A more streamlined, automated software solution would significantly improve efficiency, accuracy, usability compared to traditional spreadsheet reporting. All right, so challenges with common standard references. The current method of referencing common standards is inefficient, labor intensive, and frustrating. Manual search for material specifications. For an API 510 report, inspectors must locate material stress values in ASME Section 2, Part D, which requires extensive page-by-page searching because they are not in any specific alphanumeric order. Man, how many times I've had to go to do that for every single vessel and different material that might be used in that vessel. Heads might be made of one material, shells another, and you got to search through all these pages. What do we have here from page 2 to 424? That's a lot of pages to have to search through. Although some of them may be concentrated in table 1, table B, and such. So, year specification code requirements. Determining which code book applies depends on whether the pressure vessel was built before or after 1998. There were stress values there that had changed. Many companies may have not had access to the pre-1998 edition, creating additional frustration limiting access to crucial data. Excuse me. You have variable stress values. Stress values depending on design temperature require further lookup and verification to ensure compliance with the appropriate standards. All right, a lack of organized system. The absence of a alphanumeric sequence for material stress values, and ASME Section 2 Part D forces inspectors to manually sift through approximately 420 pages, significantly slowing down the report process. So basically, these code searches, looking through codes is so frustrating. And in one code might reference another code, and then you got two codes open now, and it might reference another one, and so forth. Next thing you know, you got several code books open all around you, and you forget what you were started with. So issues with common standard references. Numerous specs for each different pipe, nozzle, weld flange, etc. require repetitive searches for each report. So you got to go back into each one of these different standards, finding products, SDS and specific gravity values for common stored products is always a time-consuming process. Search on the web. So these examples here, for instance, you have this typical design configurations for 150-pound flanges. Well, there's 6 different types of flanges, and there's multiple sizes that you have to search for to get all the variables required for that particular nozzle or that particular flange. Okay, challenges with common standard references. Manually referencing multiple code books increases the risk of errors, slows down the reporting process, and adds unnecessary frustrations. Okay, so you have extensive manual search. Inspectors must locate values for each report based on different design specifications. For example, API 570 piping system report requires consulting multiple sources to verify compliance. Many companies fail to keep up with the latest codes due to high cost of purchasing the code books. All right, relying on obsolete codes can result in inaccurate evaluations and suboptimal recommendations, ultimately affecting safety, compliance, and operational efficiency. You have interconnected code references. Many code books cross-reference the other standard, leading to a chain of lookups. For instance, API 653 may reference a section in API 650, which in turn references yet another section within the same standard. This results in a session with multiple open code books scattered all around, making it difficult to navigate efficiently. Okay. You have determining applicable standards. Inspectors must identify the correct piping code among options such as ASME B311, B313, B314, and B16.5. These selecting the appropriate standard adds another layer of complexity. You have material and component specifications. Different pipe sizes and schedules vary based on material specifications, requiring inspectors to cross-check standards to determine the correct dimensions. Additionally, various components, weld necks, long weld necks, have unique specifications that must be verified. Okay, stress and pressure ratings. Inspectors must extract stress values from tables. For example, table A1, B31.3, based on code and design temperature. Class rating values, 150, 300 pounds, 600 pounds. See, all these have so many different variables that are connected to each of these that you got to make some determination on. Must be determined based on pressure and temperature conditions, further complicating the process. Okay. So these are some of the things you run in for when you're talking about standard codes. The risk associated with missing data, manual errors, or misreported calculations is the misdiagnosis of an asset's condition, which can lead to catastrophic failures. Excuse me. Such oversights put employees, surrounding communities, and critical equipment in harm's way, increasing the likelihood of accidents, environmental hazards, and costly disruptions. All right. So ultimately, the asset owner bears the full responsibility for insurance compliance, safety, and the integrity of inspections to prevent costly liabilities and potential disasters. You have these issues with the using the Excel for asset tracking. Without a robust Up-to-date asset tracking software, misdiagnosis and inspection interval errors become more likely. Relying on an Excel spreadsheet for asset tracking poses risks, as data cells can be unintentionally overridden with static values, leading to errors that may go unnoticed in future use. Owners of the inspection program can sometimes move on from a company, abruptly leaving behind multiple spreadsheets, just confusing the new owner of the assets, not knowing what was inspected or when. And that I've seen often. A lot of times as a third-party inspector, I'll be sent a lot of these to try to figure out what has been inspected and what has not been inspected. All right. So challenges with maintenance asset tracking in SAP or Maximo. Maintenance tracking software like SAP is not designed to function as a centralized hub for essential supporting documents such as CAD drawings, equipment specs, previous reports, or design drawings. Okay, yeah, this is just to track when the next inspection should be done, or what maintenance needs to be done from previous inspections. But it's certainly not a hub where you can keep all these different documents in one central place for easy access. An effective asset tracking database should be user-friendly and function as a comprehensive hub where all relevant design documents, inspection reports, action items, and connected equipment such as PSVs, relief valves, pumps, AOVs, etc., are easily accessible via electronic file. Here's just an example of how that would look. You have in your database, you have a design document button. You open it up, and right there is all related documents, pictures, calculations, RV specs, you name it, design drawings at the click of a button. Okay, that's a user-friendly hub, and there is no really other software out there that provides that. Okay. So you have challenges with asset tracking in databases. So many asset tracking software solutions today are overly complicated, expensive, very expensive, and packed with unnecessary features. So as a result, administrators often limit access to a small group of trained technical personnel responsible for all data entry. An ideal solution should simplify asset management, making it intuitive, efficient, and accessible to a broader team rather than adding layers of complexity. Okay. Many existing software solutions, such as UPipe, Meridian, PCMS, are overly complicated, just overly complicated. If anybody's had to deal with all these, they know what I'm talking about. They're, for what it needs to be, requiring redundant approvals across multiple departments for each inspection entry. This bureaucratic process can take days, allowing the ball to be dropped and delaying critical responses. Additionally, these systems often focus excessively on a specific CML point that require frequent inspections. All right, and it's just left up to this program to do these inspection intervals, and sometimes it needs some intelligent input to make some oversights, diverting attention from the broader asset conditions. API inspectors are often excluded from the data entry process. Okay, API inspectors are often included from the data entry process, limiting their ability to make informed decisions on critical conditions. Asset owners rely on these programs to flag issues, but they frequently fail to provide timely and actionable alerts due to negligible oversight, compromising the efficiency and the inspection process. Ultimately, the asset owner bears full responsibility for ensuring compliance and safety and the integrity of the inspections to prevent costly liabilities and potential disasters. All right. So the API Inspector's Toolbox is the solution. Okay. So this is where now we talked about the problems with all the past way outside of a software solution that causes a bottleneck, causes consumes time, costs money. So the API Inspector's Toolbox is the solution to all the asset owners and inspection companies' needs. Okay. The API Toolbox mitigates financial and regulatory risks by ensuring assets are evaluated using the most advanced and up-to-date software available. Designed for efficiency, the API Toolbox provides a structured and intuitive data input workflow, streamlining the inspection process. API reports are evaluated, or API reports generated through the platform, through the API program, Toolbox, adhere strictly to the requirements of the latest editions of API 510, 570, 653, and other related codes, ensuring that every asset is thoroughly assessed and presented in a clear, no-nonsense format. Combined with the asset management tracking database, this system delivers a robust, user-friendly solution for managing equipment, significantly reducing time and effort for asset owners and inspection companies alike. Okay, so this is a solution that just brings it all together and makes it so much easier and simpler to follow along and get these inspection reports done and to track your asset. The API Toolbox significantly reduces the time spent pouring through code books and reduces redundant data entry that is required by using Excel spreadsheets and other programs in a piecemeal effort, and it will reduce it by 50 to 70% of the time. Absolutely. But the API Toolbox, you very rarely, it's very exceptional to have to go to the codes because it's so automated. You don't have to look all this stuff up anymore. It's already into the program, and the algorithms take care of it. The API Toolbox is an automation program ensuring that calculations and evaluations are based on the latest industrial standards and cannot be accidentally overwritten. It also accounts for variations in operating conditions that might be overlooked during manual data entry, reducing the risk of errors and improving the accuracy and reliability of inspection reports. Okay. The API Toolbox is an intuitive, user-friendly program that requires minimal onboarding. Okay. One of the most consistent pieces of feedback we receive is how easy it is to use. Okay, the API Toolbox base page is designed with a cascading cascading workflow where data entered on the base page seamlessly flows into the subpages within the appendices. This eliminates redundant data entry, a common frustration with spreadsheets that require repetitive inputs for various components. Okay, the program also automates the input of standard values, including stress values that consider design temperature and build dates. Okay, pipe and nozzle nominal thicknesses based on size and schedule, specific gravity values from selected products, minimum thicknesses either calculated or referenced from standard-based tables. Additionally, API Toolbox consolidates essential code references and calculations within each module, making them accessible with a single click. This eliminates the need for inspectors and engineers to manually sift through hard copy code books, significantly streamlining the inspection process and improving efficiency. Ultimately, the API Toolbox significantly reduces office reporting time, saving both time and money while ensuring a fast turnaround that keeps clients satisfied. The API Toolbox is a solution for all the asset owners and inspection company needs. The API Toolbox Asset Manager Database, let's talk about that, is a centralized repository for all asset-related documents regardless of format. AutoCAD, PDF, JPEG, Word, Excel, PowerPoint. It accepts all of them. You just upload it and it's there in a hub per asset, ensuring seamless access and organization. How much time would that save you from having to go to different files and different within hard copy and soft online stuff? So just right there, ensuring seamless access and organization. It streamlines compliance by ensuring inspections are completed on schedule while enhancing efficiency, accuracy, and regulatory adherence. Okay. Once a report is complete, It is simply uploaded into the API Toolbox asset management database. Under the relevant asset and inspection dates are updated. API Toolbox format and required elements for API reporting meets all OSHA compliances requirements for mechanical integrity programs within a PSN program. So this is the solution. It really does help give you a robust program to meet the needs of your client, to meet OSHA needs and your inspectors. Okay. So let's talk about now what the program kind of contains. All right, it has a material library where you can look up just about any material that is that we use in our industry. It has, for you engineers out there and savvy inspectors, it has pressure calculations for pressure vessel calculations. It has above ground storage tank calculations, pipe calculations. Okay, so you can do all these different components, and you have calculations at your disposal. Material specifications. Let's talk about that. The material specs, tensile stress, yield stress, stress values, chemical components, heat ranges, hardness testing. It has the weld rod selections. It has the modulus of elasticity, thermal coefficiency, minimum desired metal temperatures, post-weld heat treatment evaluations. You have your external pressure charts, figure G's and A's, and the program actually for anything CS2, well, the program will automatically do your figure, will determine your figure A. So you don't really have to go to the charts for that, but they're there if you need for assurance. The carbon steels, it's stainless steel charts to determine B are there, but carbon CS2, which is the most common material in our industry, it will automatically calculate that. So doing external pressure calcs is almost automated to about 90%. Pipe standards, class ratings, 150 to 1,500 pound. It has weld neck flanges, long weld neck flanges, etc. It has all those in an instant. You don't have to go to the codes. It's there. Just click on any of the subject matters of interest, and there it is. All the values, that you need. Carbon steel, stainless steel, and aluminum pipe sizes, schedules, tube sizes, gauges, stress tables from table A, B, 31.3, gasket data, bolting, installation. So it's all there. All this stuff that you would have to normally go to the code for it when you use an Excel, you don't have to worry about it. It's all automated. Okay, and man, it's sweet. It takes all that frustration out of there. Sometimes we don't even know where to begin, right? So pressure vessel calculations. Here's a lot of the calculations that are available at the pick of a button, and stuff like, cylindrical shells, jackets, nozzles, heads. It has formed heads, which is like torus-spherical, hemispherical, ellipsoidal, has flat, conical sections. Exchangers, you can evaluate exchangers. Horizontal tanks per the ZIC formula. Okay, not a lot of folks have those calcs. Tower wind loads, okay, all available in the report modules. User can re-rate any type of vessel. So we have almost every component here that you would need. You could actually re-rate a vessel if you need to. Above ground storage tank calcs, okay? We have the shell calcs, the variable design point calcs, the appendix F, V, M, all that are at your disposal. Floor MRT calcs, okay? Dividing it up according to the code. General plates, critical zones, annual plates. Shells, bottom and edge settlement bulges. Horizontal tanks again. Roof calcs, nozzle, component life calcs for STI evaluations, okay? So pipe calcs. And so here's all the list of calculations that, again, you can re-rate piping here. So all this for calculations for you engineers and those who are pretty savvy at to do the calculations. So let's take a look now. We're going to go and do a live demo here, and bear with me as I try to switch over to that. Let's see, share something else. Where is it? Give me a minute. I'm trying to find what I did with my, here it is. Let's see. Let's go with that. Let's try that again. and share something else. It's moving slow on me for some reason. There it is. All right, hopefully you can see this now. This is the first, when you get into the software program, you'll come up to this page. You have to go up to inspections and select what module you're interested in, whether it's API 510, 570, 653, the asset manager, engineering data. Let's just real quickly look at engineering data. So here under engineering data, you have AST calcs, material library, pipe calculations, and pressure vessel calculations. So we just seen all that. Let's just take a real quick look at pressure vessel calcs. So there they are, and all you have to do is click on it, and it'll take you to the calculation, and you just do the calculation, and that's it. Material library. So here's material specs. Let's go take a look at that. So here, there's a list of material, everything from chrome, stainless steels, exotic steels, carbon steels. Just at a pick of a button, you have all your variables related to that. So here's some stainless steel 304, and it has all of your types of product. It has USN numbers, your tensile strength, yield strength, your stress value before and after the change in 1998, and a lot of other references. Down here, you have your welding rods, modulus of elasticity, thermal coefficients, and all that. All right. So that's your material. All right. So now let's go and take a look at the typical. So the formatting of all these modules for 510 and 570 and 653 pretty much look identical. So let's take a look at some of that. So the first thing it does is bring it, and this is going to change. This is like the first page you come to, and it has little tabulated windows that have code bytes. That again, we want to reference to certain design specs or inspection evaluations and stuff. So you just click on it, and then you can scroll through. And there's also some other sub windows depending on what you're talking about: parts and deformation, minimum. Vessels with minimum no dock and weld inspections and all this, corrosion minimum. So there's just these code bytes and references to the code where they're from. That'll save you from going to the code. It's all right there, all that information, and it's broken down into individual sections. The next thing we'll do is take a look at the report builder, and that is what is going to where this is going to bring you. This is going to switch this around to where your first thing it brings you into is your report builder. So let's take a look at that. You always have the option to click out any windows you don't want to keep your minimum to what's going on here. So this is the first thing you'll see. It'll come into what we refer to as the report base page. All right, and then you have a lot of the static data will go here. You have pull downs in a lot of ways so that you can select what best fits the nomenclature of this report. All right. And then you have the cells across the top here for vessel configuration, inspection date, type of inspections, head type, age, and this is you just put in the age, not a date, all right, how old it is from the date that you inspected it to the date it was built. And that will cascade down as the previous inspection thickness or time period, excuse me. There is your report name, and you can actually change the report name here. Okay, and then hit save after you do that. Here's the owner. This is the person writing the report. Here's the inspector, and usually you can keep the inspectors here. You just put them in. Click on this green button, put your inspection name in there, and it'll come up automatically with your certification, client, employer, your length or height, your city, your state number, if it's a pressure vessel under national board inspections, state inspections, your vessel ID, location, year built, all that, national board number, inside diameter, serial number, maximum allowable working pressure. A lot of this stuff like maximum allowable working pressure, maximum allowable external working pressure, design temperature. All this will cascade forward. So the more that you go in deep into the cascade of this information, the less information you have to put on it. Okay, and you need to pay attention to what it's asking for. It's asking here for an inside diameter. So make sure it's not the outside diameter that you're putting in there. It makes a difference for pressure vessel. And then it breaks down into different sections. All right, so you have this upper box for your main section, but if it's a heat exchanger, you have a second uh, chamber here that is completely independent. It can have its own temperature, its own pressure, its own medium, and all that. So you select what you need here. If you don't have a second one, just hit this disable your chamber 2, and it's just going to report on a single chamber vessel. Okay. Um, yeah, so we're going to do that. And so this is where you put your static data. You can put a cover image here. Okay. That adds to it. You don't have to, but you can. You have long-term, short-term analysis on these. That if you do that, if there's a need for that, you can just click on that, and it'll add an extra LTSTH. Okay, and you just follow along, put in the needed information in the boxes. You have a cover text here. Update that if you're doing a brand new one, because you can either start a brand new one from scratch, everything's empty, or you can copy a report, which is what I normally do, or you can use a template, do it in an Excel spreadsheet, and then upload it. Okay, so if you're going to do a brand new one, start from scratch, then as you go along and put information in here, and you kind of wait till you got all this filled and you hit save, it will update this cover text with certain information that you had inputted above. Otherwise, you're going to have to change this manually for the other types, like copying a report or uploading. Well, uploading, you'll probably have already done it. So, okay. So next thing you're going to do, you're going to make sure you hit your save button. You're going to go into the report appendix. And a lot of times you've already preliminary done some documents and saved them into PDF. So, and a lot of what I do here, so you have your appendices, you have thickness measurement record, mechanical and technical calculations, your inspection drawings, checklists, photos, manufacturer data sheets, like your U1 data sheets, your NDE records, your UT Cal record, your API cert, your NDE certs, and anything else you want to add here. Okay, you can add it right there. These will come with default, like the calcs will come with default calcs here. Normally it's your shell, formed head, and your component life and your nozzle life. But you can easily, let's say it comes in here with the nozzle. You have your nozzle here. If it's not applicable, there was no nozzles that you did UTs on, you could just get rid of it like this and just arrange them in any way that you want. All right, and so what'll happen here is you'll go in here. Like I say, I actually do my spreadsheet for this. So you have a spreadsheet. I usually input the spreadsheet and then I upload it here. And when I hit import, boom, in an instant, it automatically fills what you need here, and it will select your the actuals for each component, which is usually the lowest reading out of each CML. Okay, make sure you save that for it to cascade forward. Sorry that it doesn't have data already. I could have picked another one, but and then it cascades forwards, and then you go into each of the components. In this case, it's cylindrical shell, and a lot of this information is already cascaded from the front. Put in the necessary materials. Well, this will actually cascade from the front, from the appendix A, and it will automatically give you your stress value. You have to input your E value. You got your minimum required thickness for that component. Then you go down here for your remaining life calcs and your pressure calcs for the thickness anticipated at the next inspection, according to the code. So that's basically what you got here for doing your reports. You want to do your drawing in either CAD or whatever, print it to PDF, upload it. Here you have an inspection checklist, and if you have your own, fill that out, PDF it, and upload it. Otherwise, you could go in here, and there's a 510 checklist here, and you would click what's relative to your inspections, and if you click off, it will close this out. It will not be a part of the checklist if it was not applicable. In this case, this shell's external. Well, this was insulated, so you really didn't have much to look at it here. And as you go down here, there's other stuff, and you can always add more stuff to it down here, where it's your notes are down here, and all of and such. So okay, so whatever's applicable, you click. Whatever's not applicable, you unclick. Okay. And let's see here. So manufacturer's data sheets, and you can add to these. Let's say manufacturer's data, you got a U1, you got a design drawing, but you got several others. You could always add to that here. Just pick which appendice it was, and then you just pick your subject header, and then you can add whatever here, and then hit add new text, and then it will be in the drop down out here for you to pick. Okay. So the photos and all this stuff should be in PDF, and then you can upload it. Now, then from here, you would go to your write-up. And like I say, all of these modules are basically the same, have the same look, same formatting. You have your report write-ups. So here, whatever is applicable, you can keep clicked, and if it's not applicable, unclick it. If you just don't like the way it's the nomenclature for it, you can change it. You just click here and change the nomenclature. Okay, which I'm not going to do. And then you have in this side, you have your findings, and in this side, your recommendations. It breaks it down so that this kind of acts as a cut sheet. You know, you can just usually it's a 1-page, 2-page, maybe issues of things that need to be fixed. And you can just print it when you print out your report. That is, you can just separate that page, give it to your maintenance folks, and they go out and do the fixes. It's broken down per component of each asset. Okay, and then you have the executive summary. And the executive summary here is usually a collection of some of the more critical things you've written in the body of the report, and you can just add them here. Okay, and then always make sure you save. And these dates here will automatically be produced based on API 510 corrosion rates or max allowed. Okay, you don't have to worry about those are automated. All right, you can change it if you want within the calculations. So that's basically the software for the inspection part and the engineers. The engineering, we went over the engineering calculations and inspection reporting. Now, real quick, I'm going to take us to the asset manager for you tank owners out there, or you plant owners. Okay, so here you is where you can start tracking your data, your assets. You would put in a client name, location. Then we got it broken down into process vessels, tankage, and process piping. So if we go in here to the process vessels, okay, we have what we call tier 1. So tier 1 will have a list of your equipment, the ID, the description, the type, state number if it has it, national board number if it has it. Let's find one that has some of this information. Yeah, so here we go. Here's one for the national board. Next internal inspection, next external inspection. And if you want to do a list of them, you just come here and let's say you want to see what's going to be due for next month for the external, hit go, and there's what's due for next month. Okay. And the same thing for internal inspections, UTs, and when you query for external and internal, if there's UTs due associated with that, they'll also list them. But here you can list them independently, and national board inspections. Okay, and here anything that is overdue will show in red. Okay, so that gets your attention, and then you want to see more about that asset. So what you do is just click on that asset. Let me find one that here. Here we go. Let me go to this one. And all the data. Now, this is your hub. This is where everything is located for that asset. You don't have to go to any other file, hard file, electronic file, anywhere, as long as you have uploaded them here. Okay, so first thing is you want your vessel documents. So let's see what we have here. Let's see, we have an image of this right here. Look at that quick. Boom, you want to see what that particular item looks like? There it is. Your mod drawings, modified drawings, PNIDs, info, PSV jacket. Okay, and anything U1 data sheets can go anything in any type of file, document, PDF, JPEG, you name it, PowerPoint, Excel, all right here at the touch of a button. Okay, can't beat that. Then you have your inspection reports. They come down here, and by date, it's listed by date, and all your reports here at a click of a button. So, and here, by the way, is what a typical report would look like for a pressure vessel. So remember we talked about having the photograph of it, image of it to start with, okay? And then executive summary, there is your, and this is all, just at a click of a button, this will be printed out, your vessel data, your inspection results, and all that. So the checklist, photographs, everything right there. And then, of course, this is just where you put your static data, and you can print that. Maintenance people want to know, or somebody wants to know about that piece of equipment, print it out, and it gives you all the dates it was inspected. It all shows up there, and all the static data. Okay, and then you can connect that to PSVs right here. Here's two PSVs, one on one side, one on the other, and you have all the data that you need for that and the inspections for that. It's that simple. There's no other program out there like that. No PCMS, no UPI, none of it that has a repository like this and has easy access and is user friendly. So I'm going to have to leave it come to an end right here now and bring it back to our man guy. Give me a second, please, to figure out how to get back here to share something. Hopefully this is the right one. No, it's not. Yeah. Okay, let me. Why is this not doing this? Okay, here we go. Not too savvy here with this online presentation here. Here we go, I think. So anyway, so let's go down to where we left off right here, and let's go to poll questions.
And Jeff, we're still seeing your title slide, but I think that's okay. So yeah, folks, we've got two quick poll questions just to help us gauge kind of, how we can follow up, if at all, with you all. And, also just for a lot of you, this is the first time you've seen this type of solution. So we'd like to hear kind of, where are your pain points in API inspection with the first question here, just so that we're clear on where we can improve our own software in the future as well. So we'll give you a couple more seconds to answer this one.
You're asking towards me. I'm sorry about it. What is your biggest pain point in API inspection? Of course, it's a reporting. If you don't have a software solution, then you've got to piecemeal that thing together, and it will take you 2 to 3 times longer to do a report. And it's frustrating because you got to search for things in different areas, files and all that. You got to put it together, and you got to do repetitive input. So it's definitely the report modules and not having a software solution.
Awesome. Okay, so that was our poll number one. I think we've got one more, and then we will dive right into questions. So for this one, if you all liked what you saw from Jeff, great. If you'd like to kind of get your hands onto the software to see how you could use it for yourself, let us know. Go ahead and select yes there. Otherwise, we will leave you alone in terms of what you hear from us, and um, you'll just get the recording after this. So we'll give you one more minute there. So while you all answer that poll, I am going to start with the questions here. So first question for you, Jeff. Does the API Toolbox cover regulatory regulation safety codes for any provinces in Canada?
No, no, not really. I mean, I think a lot of them still do follow kind of an OSHA thing, but anything specific to Canada, no.
Okay, great. And for everyone else, again, if you do have questions on the presentation you saw in terms of how the software operates, there is that question box on the upper right-hand corner. Feel free to open that and type your question in. We'll try to get it here. Okay, a couple more. So, Jeff, for folks that do third-party contracting, how does the software handle multiple companies using the same assets?
I'm sorry, repeat that.
So, I have one question that says, we do third-party contracting. How does the software handle multiple companies using the same assets?
Multiple companies using the same assets. Well, I mean, the asset is the asset. The report would, it seems like to me, the report would go to all the companies involved. As far as tracking, you could use the asset management database and track each one of those reports each one of those clients individually. All right. And that's advantageous because then you have all their reports in one location. You don't have to go hunting for them. You just go to that client, you go to their tier one, you select the asset, and in there you can keep all your reports. So as far as the only difficult thing I would see there would be that if you have one asset that goes to 3 clients, you might have to change the client name on each one of those. And that would probably be best done in PDF.
Okay, great. One more question. Is there customization? And I think you kind of covered this in your demo, but is there customization to the checklist based on our API needs?
Well, you can click on and off what is there, and you can add other areas of interest. So yes, there is a bit of customizing for that.
Okay, great.
And you can also have your own checklist and upload that. Put it in PDF and upload that.
Awesome. So those were the 3 questions that came in. Any other questions from the group? Feel free to type them in now. Otherwise, I think we're in great shape, and I think we hope you all have a great day. So just to answer, you all will get this recording in your inbox in the next 48 hours if you've got questions. And for those of you that selected getting information or resources, we will be sure to follow up there as well. So with that, Jeff, thank you for the presentation and demo. And for everyone else, we hope you have a great day. Thank
My
you.
pleasure. Yep.
All
Yeah,
right.
have a great day.